In section 4.1 we talked about sampling, surveys, and that sort of thing. In section 4.2 we talked about observational studies and experimental design. In section 4.3 we talk about how we can interpret the results of different experiments, of the different types of studies, and also some ethical considerations. So let's first of all talk about how we can interpret the results. This is known as the scope of inference. The scope of inference refers to the type of inferences or conclusions that can be drawn from a study. The types of inferences we can make, either inferences about the population as a whole or inferences about cause and effect, are determined by two factors in the design of the study. Factor number 1, were individuals randomly selected from a population? Factor number 2, were individuals randomly assigned to groups? So, if individuals were randomly selected from a population, we can say that they are representative of the population. Therefore, any results we get can be generalized to the population. So yes, we can generalize to the population in this case. Were there individuals randomly assigned to groups? That means we have an experimental design where there's some sort of a treatment group, and we then can have evidence for cause and effect. If we see a difference in the treatment groups, there would be evidence for cause and effect. So if the individuals are randomly assigned to groups, we can possibly find evidence for cause and effect. Now in the second group, now let me point out though that this is rarely ever happens. We rarely ever have both types of randomization in a situation, because if we're doing an experiment, we rarely have the opportunity to randomly select our subjects. If we're doing a survey, then we're usually not randomly assigning to groups. So usually both of these don't happen at the same time. It's usually one or the other. So here's a situation where individuals are randomly assigned to groups, but we didn't randomly select those individuals. So in that case, no, we cannot generalize to the population, but yes, we could possibly find evidence for cause and effect. Most experiments fall in this category. In the top right-hand box, we've randomly selected from the population, so yes, we could generalize our results to the population, but we have not randomly assigned anybody to groups, so there is no evidence for cause and effect. Some observational studies are in this category, as well as most surveys. So observational studies, surveys. The last group is where we didn't randomly select from a population, nor did we randomly assign to groups. So that means in this case we cannot generalize to a population, and we cannot find evidence for cause and effect. Some observational studies are in this category. Now you might think, what's the purpose of the observational study if I can't do either of those two things? Well, I could still find a possible association between two variables, even if it doesn't necessarily apply to everyone. It might lead to further study or lead to creating an experiment then to determine cause and effect. So let's look at this example and see how these different categories apply to this example. So here's the situation. Many students insist that they study better when listening to music. A teacher doubts this claim and suspects that listening to music actually hurts academic performance. Here are 4 possible study designs to address this question at your school. In each case, the response variable will be the student's GPA at the end of the semester. Number 1, get all the students in your AP Statistics class to participate in the study. So nobody was randomly selected in this case. Ask them whether or not they study with music and divide them into 2 groups based on their answer to this question. So they were not randomly assigned. Number 2, select a random sample of students from your school to participate in this study. So we randomly selected our sample. Ask them whether or not they study with music on and divide them into 2 groups based on their answer to this question. No random assignment. Number 3, get all the students in your AP Statistics class to participate in a study. Okay, so no random selection. Randomly assign half the students to listen to music while studying for the entire semester and have the remaining half abstain from listening to music while studying. Probably not a very ethical design, but they were randomly assigned to treatment groups there. Number 4, select a random sample of students from your school to participate in a study. Randomly assign half students to listen to music while studying for the entire semester and have the remaining half abstain from listening to music while studying. So we have both types of randomization in that number 4. So the question is, for each design, suppose that the mean GPA for students who listened to music while studying was significantly lower than the mean GPA of students who didn't listen to music while studying. What can we conclude for each design? Well, in number 1, there was no randomization used at all, so I cannot conclude that listening to music caused lower GPAs, and I can't say these results represent all students. So basically kind of a worthless study. However, I suppose if there was an association, that might, I guess it's not totally worthless, it might lead me to create a better study to follow up on those possible ideas. Number 2, we randomly selected the students, so I can generalize my results to all students, but I can't conclude that listening to music caused lower GPAs since I did not randomly assign students to treatment groups. Number 3, there is evidence that listening to music lowers GPAs since I randomly assigned to treatment groups, but these results may not apply to all students since I only used AP Stat students and didn't randomly select. Number 4, when I use both randomization techniques, then I can say there's evidence that listening to music lowers GPAs, and I can generalize these results to all students.